So make sure you have the 3.3 on it. And before I talk through this example right here, I'm going to have you guys watch a video by that same guy that we watched before, showing how to do the problems if the value in front of the x squared is not a 1. If it's not a 1, we can still draw the x, but we have to modify it slightly, because otherwise we're not going to end up with the same answer.
Now, for this lesson, I'm going to talk to you guys about rainy days. Now, I don't know about you, but when I was in school, I didn't like rainy days too much. Why? I always had to stay indoors. I always had to walk under the roof to stay dry. And whenever I looked outside the classroom window, it was never sunny outside, which gave me a very gloomy feeling on the inside as well. So whenever I saw something like this in class, I always felt like it was a rainy day, and it gave me that gloomy feeling because there was a coefficient in front of the variable squared, and they were asking me to factor. The other thing I noticed, I couldn't take the greatest common factor out of any of the terms, so that coefficient couldn't just be factored out. But then I realized, on rainy days I use an umbrella, so for this factoring method, I'm going to go ahead and use an umbrella as well. I'm going to teach you guys how to factor using the umbrella method. Let me show you what I'm talking about. I see something like this and it gives me that gloomy feeling, so I just go ahead and I multiply this 2 times 9, and I draw that arrow, and I drop down this positive 9. So I'll put that here, and I go ahead and make my x. We cannot forget about the x. And then I just go ahead and put 2 times 9 is positive 18. So whatever these two numbers multiply to, I put right here. So now I just ask myself, what multiplies to a positive 18 and adds to a positive 9? That would be a positive 3 times a positive 6. Great. Now normally, when factoring using the x method, we're done. But whenever there's a coefficient and we use the umbrella method, we go ahead and do one more step, and that's taking it to the box method. So let me go ahead and take this to the box. So I draw a box here, and I put the far left coefficient into the top left box. I'm going to put a positive 2 there. And then I take the far right number and I'm going to put it in the bottom right corner of the box. And then these two numbers can go any which way. So I'm going to go ahead and put a 3 here and the positive 6 here. Now, what I'm going to do is I'm going to look at this first row. I'm going to look at 2 and 3. And I'm going to take the greatest common factor out. So if I do that, I would know the greatest common factor is just a 1. And it's a positive 1. Once I do that, everything else is easy. All I do is divide 1 into 2, and that gives me 2, so I'll put that answer there. I'll divide 1 into 3, and that gives me 3. And then I just take this number and I divide 2 into 6 to get 3. Now, these two numbers right here, 1 and 2, the ones that are part of this top left corner, they're going to contain my variable. Since we only have x squared, we're going to put an x here and an x there. And since there's no sign here, that's going to represent it as a positive, right? So let's go ahead and put that positive sign. And this would be a positive 3, right? So now we can see we have our binomials, and this will be the same every time, which is why the umbrella method is really cool. So now we just say that 2x plus 3 times, and then that's 1x, so we could just write x plus, and that's a positive 3, so it's plus 3, is our factored answer. We went ahead and factored this. Now, I know it might seem like it takes long, but it sure beats guessing check because now we know we got the answer right. And if you want to check it, go ahead and FOIL it out. You'll get that as your answer.
Now, his method that he uses, I use it to a point, but when he gets and starts doing the box method, I do something a little bit different instead of doing the box. So this example right here that's on your note page, anytime it's quadratics in the form ax squared plus bx plus c equals 0, whether that's a 1 for the a or a number, we can a non-1 number in front of the x squared, we can always use the x method if it's something that factors. Okay, so in this case, since it's not a 1 in front of the x squared, his umbrella method says, and some people call it like over the rainbow or whatever because it kind of looks like a rainbow also, you always multiply those numbers together. So I would multiply the 10 with the negative 6, and then that goes down here. So this is the same as the 10 times the negative 6 for the negative 60. So right here, as just like a little note to myself, I'm going to put that this number that you put down here is a times c. Because if it's in this quadratic form, the a was the number in front of the x squared, the c was the number without the x. So the a and c are being multiplied down here. And then the value that you put up here was just the middle term, which in the quadratic form, that's the b. So you come up with two things that multiply to give the ac, multiply to give negative 60, that add to give the b. So two things that multiply to give negative 60, that add to give 7, would be this 12 and negative 5. 12 times negative 5 is negative 60. 12 plus negative 5 is 7. So far to there, I'm the same as what he was doing. And then this is where I go a little different. Instead of drawing the box like he did, I go and I take whatever the a is, which on this problem was a 10, and I divide each of these numbers that I put on the side by the a. So that 12, I'm dividing by the a on both sides. So I divided them each by 10. And after I divide it by the a, you have to reduce it. If the fraction can reduce, you have to reduce it. So negative 5/10 reduces to negative 1/2. And then 12/10 reduces to 6/5. And now I'm ready to write my answers out as factors. So to get the factors, all you do is you do your two sets of parentheses, and my variable was an x squared, so I'm going to use an x in each factor. So you take, if you have a fraction on this side, you take the denominator of the fraction, which in this case is the 5, and that goes in front of the x. So I write it as 5x, and then you go plus the numerator, so plus 6. So then on this other side where I had the negative 1/2, I take the denominator, which was 2, put it in front of the x, and then put the numerator, which was negative 1. So this is what you would go to if the question just said factor. And then if the question said solve, I would then set each factor equal to 0 and solve for x. And if I were to FOIL this out, I would get this original answer up here. Now, a lot of the times people will try to put it like x plus 6/5, x minus 1/2. And it's okay to do it that way if you're solving the equation, because then that's easy to solve. But if the question said factor and it didn't want you to solve, this would be wrong, because if I were to FOIL that out, x times x gives me x squared, not the 10x squared. But if I make sure I put the denominator in front of the x's, then I can go 5x times 2x and get out my 10x squared. So anytime it says factor, you have to be able to FOIL it out to get the the original problem. Okay, so that's why I don't just put x plus 6/5 and x minus 1/2 like a lot of people are tempted to do. Okay, so these problems right here, these are something where I would do that umbrella method. The value in front of the n squared is not a 1. So I have to multiply the a and the c value together. So 3 times 2 would give me a 6. And then the b value goes up here. So I'm coming up with two things that will multiply to give me a 6 that are going to add to give me a 5. And what would those be? Okay, 2 and 3. And it doesn't matter which side you put the 2 on and which side you put the 3 on. After you've come up with those numbers, this is a step you can't forget to do. You have to go and divide both of those numbers by the a. So I'm going to divide the 2 by the 3 and the 3 by the 3. And then if it will reduce, you have to reduce it. Now my answer for the factor, the denominator, if you have a fraction, the denominator goes in front of your variable. My variable was an n. So I'm going to have a 3n, and then you just put your numerator next, so that was a positive 2, so I go plus 2. Now in the other fraction, in the other parenthesis, there was no fraction, it was just the number 1. So then that one I would put like I normally did, where we didn't have, where the coefficient was a 1 in front of the variable, and just put the variable plus and then whatever number you had there, which in this case is 1. And if I were to FOIL that out, I would get this original starting problem. 3n times n is 3n squared, 3n times 1 is 3n, 2 times n is 2n, so the 3n plus 2n would give me the 5n, 2 times 1 gives me the 2. So I know that that's factored correctly. This next one over here, same thing, because the variable, the number, the coefficient in front of the ng squared is not a 1. I have to multiply the a and the c together. So I have to go 3 times 2, which gives me 6. And then you put the b value up at the top. And then it's coming up with two things that multiply to give 6, that add to give negative 7. And what would that one be? Perfect. Both of them are negative. Negative 6 times negative 1 is a positive 6. Negative 6 plus negative 1 is a negative 7. And then I'm not done yet because I have to go and divide them both by the 3, the a. And then the negative 6 thirds reduces to negative 2. Now I can put my two factors. My variable was a g. And then I'll just go g minus 2. And then the one with the fraction that I have left, the negative 1/3, the denominator has to go in front of my variable. So I put 3g, and then I put the numerator, which is negative 1. In order to do this first one, I always want mine to be written in standard form, where you have like the ax squared plus bx plus c. I want to have it in descending order, or in this case, the m squared first. So I'm just going to rearrange all the terms in the trinomial. So I have n squared minus 3m minus 4. So always just make sure it's in descending term. And now I can't factor out a GCF because the GCF would be 1. So I get to go immediately into the x method. Now this one's easy because it has a 1 in front of the m squared. So I don't have to worry about multiplying 1 with negative 4 because it's just going to be negative 4. My numerator is, the top is negative 3. So then what are two things that multiply to give negative 4 that add to give negative 3? Okay, good. Negative 4, positive 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. And then if I were to divide by the a, which in this case is 1, it doesn't change these values. So then this factor just ends up being m minus 4 times m plus 1. Okay, so I just switched the problems. So this one right here, anytime it has the equal sign, this one right here, the instructions want us to solve it. So anytime we're solving and it's a trinomial, we want it to equal 0 before you even attempt to factor. Always make it equal 0. So I would have to start by adding the 15 to each side. So I get 4a squared minus 16a plus 15 equals 0. And then, since the value in front of the a squared is a 4, that means I'm doing the umbrella method. So I have to multiply the 4 with the 15. So 4 times 15, that gives me 60. And then the b value, which was negative 16, will go up here. So we're going to come up with two things that multiply to give 60, that add to give us negative 16. What was that? Okay, so you're saying negative what? Okay, so negative 10, positive 6.
Negative 6.
Good, negative 6. Negative 10 times negative 6 is positive 60. Negative 10 plus negative 6 is negative 16. So that one works. Now this is the step you can't forget. You have to remember to go and divide them each by whatever the a was. And in this case, the a was 4. So I go divide 4, and then you have to reduce it if it can reduce. So 2 divides into both the 6 and the 4. So that would reduce to negative 3 halves. And then 2 divides into both the 10 and the 4, so that would reduce to negative 10 halves. Now that I have that, I'm going to write it as a factor. So if there's a denominator, the denominator goes in front of your variable. My variable was an a. So my factor will be 2a minus 5. So the denominator with the variable, and then you put the numerator next. And then in the other factor, the denominator was a 2. So I put a 2 and then the variable, which was a, and then I put the numerator, which was negative 3. So this right here is the factors. But then on this problem, I want to solve. So that means I now have to take each factor, set it equal to 0, and see what a is. So I would say 2a minus 5 equals 0, and 2a minus 3 equals 0. So I just add 5 to both sides and get 2a equals 5. Then I divide by 2, and I get that a is 5 halves. Over here, I add 3 to both sides and get 2a equals 3. Then I divide each side by the 2 and get a equals 3 halves. So a is 5 halves or 3 halves. Now if you notice up here, the solutions ended up just being the opposites of those right there. So if it wants the solution, it's going to be the opposite signs of whatever you had on the sides here. But if it wants the factors, you have to write it out that way. Thank you. I said 3 halves and wrote 3 over 3, which would be 1. Thanks for pointing that out. Okay, now this problem right here, I will still do the umbrella method. So I would multiply the 4 with the negative 3 and get negative 12. And then the b value of negative 3 would go up here. I'm trying to come up with 2 things that multiply to give negative 12 that are going to add to give me negative 3. And what might that be? Okay, if I tried 3 and negative 4, that does multiply to give negative 12. But 3 plus negative 4 is negative 1 instead of negative 3. So the 3 and negative 4 won't work. Okay, yeah, nothing's working. So sometimes it happens that these problems you can't factor. Okay, factoring is not always like a guarantee. If you can't come up with something, then that may be okay. So if that's the case, this one cannot factor, so we just write it's prime. We're not able to factor it. Now, if this had said equaled 0 and said it wants us to solve it, there is a solution, but we just can't factor to find the solution. Okay, so the factoring method of solving equations won't always work. And that's why later on in this unit, you guys will learn something called completing the square and the quadratic formula, because those always work where factoring doesn't always work. But if factoring works, I think it's quicker to factor than it is to do the quadratic formula or completing the square. So usually we'll start with the factoring, and then only if we can't come up with something, then we usually switch to a different method of solving an equation.